In this paper, we present a study comparing different navigation methods for visualizations in immersive environments. Interactive navigation allows people to freely rescale the visualization and change viewpoint. Such interactions are essential for data analysis, especially for large datasets. Pan, zoom, and overview plus detail techniques are well studied and widely used for navigating visualizations on a 2D screen. However, it is unclear how effective these techniques are in immersive environments. We also don't know how to adapt these techniques from 2D to a more embodied environment. In this paper, we design and evaluate overview plus detail and zooming interfaces for scatterplot in virtual reality. The overview is a minimap of the detail view. We attach the overview to one controller so the user can easily access it or hide it by an embodied interaction. Furthermore, we shrink the size of the overview by default to reduce visual clutter and allow the user to enlarge it by simply putting the other controller inside. The user can also grab the overview, move or rotate it with the other controller. In the overview, we indicate the user's position as a green cube. We also use a transparent cone to indicate the user's viewing direction. We call these components the point of view indicator. The point of view indicator is synchronized with the user in real time, so the user can know his or her position and orientation at all times. This is useful for many scenarios. For example, he or she may notice that the target is on his or her left in the overview. Then he or she only needs to turn left to find the target in the detail view. We also allow the user to use the overview to teleport in the detail view. Let us first introduce the drag and drop teleportation. The user can pick up the point of view indicator and move it to a new position, then release it to teleport. An alternative way to teleport with the overview is point and click teleportation. This time, the user only needs to move the controller to the target and then click to teleport. Let us then look at the zooming interface. We implement the pinch to zoom gesture. We also integrate rotating into the gesture to allow the user to rotate and zoom at the same time. We ensure that the two controllers are both latched to the visualization, so the user can have a smooth interaction experience. We designed a user study to evaluate the effectiveness of these two techniques and their combination with 4 conditions: room-sized interface with an overview, zooming interface, and zooming interface with an overview. Next, we are going to introduce our tested conditions. In the room-sized condition, participants can physically move around as well as use the standard pointer teleportation. These interactions in VR are equivalent to panning in a 2D interface. With an overview, participants can still physically move around and use the pointer teleportation. Participants can also use the overview to find the target. And teleport. In the zooming interface, participants can manipulate the visualization by rescaling it, moving it, and rotating it. We also provide conditions that has both overview plus detail and zooming, so participants can manipulate the view, move in space, and also use the overview to teleport. Please refer to our paper for the results of our user study. Thank you very much for reviewing our paper.